When we're talking about binder jetting, what we're really talking about is the fastest, most production-ready form of 3D printing in the world. Binder jet 3D printing can really transform just about any powder, metals, ceramics, sands, even garbage, into highly dense precision parts. And the reason it's so fast, the reason it's so production-ready is really simple. Unlike those other forms of 3D printing where you've got a little tiny laser or a little tiny nozzle putting out small amounts of material, we've got a big wide area print head depositing huge amounts of binder precisely where we need it according to the bitmap we've generated, and on a layer by layer basis, there is absolutely nothing faster. And we can take those green parts and sinter them all together in a furnace that fuses those particles together, and there's nothing faster, more affordable on a per part basis. Each layer can be printed lightning fast, just like sheets of paper. All 3D printing starts with the digital file, and creating a part for binder jetting is easy and simple. The most important thing to know is that when you eventually sinter your parts, it's going to shrink, and you're going to need to scale your parts up by about 20% to adjust for that. But once you have your final design, our software automatically nests the parts in the print bed so you can efficiently print as many parts as quickly as possible. In binder jet 3D printing, powder and powder management is actually one of the most critical parts of the process and one of the most complicated to manage. We're 3D printing the finest cuts of powder out there, ultra-fine MIM powders down to less than 5 microns in size. Think baking flour. And the reason we print these tiny particles is that they give the best bed accuracy, surface finish, and density. Ultimately, this is what gives you the best quality part. Okay, so let me tell you what happens next. We figured out exactly how to print your files, and now it's time to load it in the machine. On our machines, we have a variety of process settings depending upon what metal you're using, depending upon the substrates and all those settings. These are things we've been refining for years. So let me tell you about one of the most exciting parts of this machine. We've got our own patented direct-to-bitmap software that we use that precisely aligns every single drop in our printing engines with every single edge on your part. That's how we hit these tolerances, and that's how the magic happens. We spread that fine layer of powder, and then we print these super fine drops on top of it that glue everything together. Those print heads can be running anywhere from 400, 800, 1200 dots per inch, giving you feature sizes 60 microns, 30 microns, 15 microns. All of this happening in an automated layer overlay way in speeds that are just unheard of. On our InEvent Plus, we've got our speeds down to 13 seconds on some of our materials, and we're pushing those limits every single day. This process just gets faster and faster and better and better. So let me tell you a little bit more about this AAACT system and what it actually does. AAACT brings our bed density deviations to less than 4% across the entire volume. Less than 0.4%. That's kind of an amazing number to get any powder to get that ordered. But what it enables us to do is these incredibly quick print speeds. So when we talk about going from a 1-minute layer to a 20-second layer, a lot of that comes down to ACT. And the way this print process works, as I say, it's totally automated. We spread a layer of powder, we print a layer image, and we dry that to get ready for the next layer. And it's lather, rinse, repeat, over and over, layer, and before you know it, you've got those parts and they're ready for the curing. There are a lot of questions about curing and why we do that. So in binder jet additive, what we're actually printing is a liquid glue. And once it gets into the powder bed, that's not quite enough to hold everything together. So we have to set it thermally. And when we run it through our thermal setting process, a series of cross-linking and other reactions happen that actually makes that binder hard and strong and gives it the body it needs to survive the sintering process. After your part's cured, you need to remove it from the powder bed and prepare it for sintering. Sintering is the final step of the binder jetting process for metal. It's also the step that really proves whether you've printed a structurally sound part in all those prior steps. Any problems you might have had with your 3D print will be exposed in sintering with poor results. That's why at X1, our entire process is tightly focused on delivering highly dense green parts, because the better your green density, the lower your distortion, the lower your shrinkage, and the tighter your tolerances. It's the key to delivering a high density precision part. We've been doing this 20 years, and with binder jet metals, it's just amazing some of the products we've come up with. When we talk about materials diversity, there's nobody that can even come close to what we do here in binder jet. What we do with these things is we can take metals, we can take sands, we can take the ceramics in between, and we can combine those into being cermets and other kinds of exotic things that nobody else can touch in this entire industry. When we talk about speed, there's nobody out there that can touch anything even close to binder jetting. If you want to talk about pounds per hour, layers per second, millimeters or inches or whatever, there's nobody that can outperform us in terms of quality and consistency. When you look at our printing engines that we're using now, we're using processes that can be anywhere from a 60 micron resolution down to 30 and down to 21 in some cases. That's not something you're going to do with laser. That's not something you're going to do with e-beam. It's not something you're going to do with material extrusion. That's something you're only going to get with binder jetting.